Okay, question 4 then, of homework 5 on radians. Here we've got another classic trig equation, but involving an identity to help to start with, because we've got a mixture of sine and cos in the same equation. That cos though is squared, and of course you can always change a squared trig function into a different one. So in this case then, we're going to change the cos squared into 1 minus sine squared. Okay, and that's because of course sine squared plus cos squared equals 1. So that's the identity we're using. Quick rearrangement then to get 1 minus sine squared. Okay, multiply out the brackets, tidy it all up. We've basically got a quadratic structure here, a sine squared, a sine, and some numbers. So we've got a quadratic structure. So we're going to expand the brackets, bring across the 5 sine x, make sine squared x positive, and then we're going to have the quadratic. So there we go, expanding the brackets. I'm going to bring across the 5 sine x as well. Okay, tidy it up a little bit, but unfortunately that's a negative sine squared x first, and then a negative 5 sine x, and then a positive 3. So I'm going to tidy that up by multiplying 3 by minus 1, 2 sine squared x plus 5 sine x minus 3 equals 0. Okay, so that's my quadratic equation. Effectively, I'm now going to try and factorise, hopefully, first of all. It feels like it should factorise. Let's see. So I'm going to put 2 sine x at the front of that bracket, the sine x at the front of that bracket. Okay, 3 times 2 is 6. 1, then the difference between 6 and 1 is 5. This feels like it should work. I want 5 to be. I want positive to win, so I'm going to make that a plus 3, so I get a plus 6 sine x. Make that a minus 1, so that's 6 sine x minus 1 sine x gets me the 5 sine x, and of course minus 1 times 3 is minus 3. Okay, moving on from there then, setting each bracket equal to 0 leaves me with sine x equals a half there, and sine x equals a negative 3 over there. Now this one's great, because of course sine x only goes between 1 and minus 1, so it doesn't go down to minus 3, so there's no solution to that one, which is nice because it saves me a little bit of work. So the only one I need to really work on now is this, sine x equals a half. Okay, as normal, just inverse sine first of all of a half. Inverse sine of a half is 30 degrees, but of course we're dealing with radians here, so that is then 1/6 pi. So making sure that your calculator is in radians there. If you do inverse sine of half, you get 1/6 pi, notice. Okay, but give yourself some space for some alternative answers. Okay, we're dealing between 0 and 2 pi, but it's a fairly straightforward case. 0 to 2 pi, of course, is 0 to 360 effectively. So I'm just going to do a cast diagram here. 0 and 2 pi. Put on my angle of 1/6 pi there. Oops. My initial angle. There we go. Cast there, or all stations to crew, as my teacher taught me when I was in sixth form. Right. Sine quadrant, other sine quadrant is over here. It's a nice positive angle to start with, so therefore it goes into the sine quadrant in the normal way. Angle is always to the horizontal. There we go. And what is that angle? Well, it's pi, which has gone all the way around here to pi, but then subtract 1/6 pi. So 1 pi subtract 1/6 pi is 5/6 pi. And that's it, because by the time you come around again, you get to 2 pi and you stop. So they're the only 2 possible answers. And if you had done the graph instead, quick little look what that would look like. Sine curve. There we go. Go up at 1/6 pi. Up, along, back down again. And there is pi, take away that 1/6 pi, and you get your 5/6 pi. Okay, that's the end of question 4.